here we go. Here's the last of the three types of problems I want you to be able to work. Given this function, and functions can be written as f of x or g of x as well, but I tend, in this subject, I tend to just write them as y. Given y equals to 2x to the fourth minus 3x squared plus 4x minus 5, do the following. Stretch it by a factor of 6, shift it 7 units to the right and 8 units up. What is the new function? Now, there was no reflection this time. Reflection would mean I would have a negative in there. But stretch by a factor of 6 means I'm going to what? I'm going to multiply this entire thing by 6. So y equals to 6, and I'm going to use a bracket here. Now the 7 units to the right means I'm replacing x with what? X minus 7. Alright, so positive horizontal shift means replace x's with x minus 7. So I'm going to have this 2, parentheses, x minus 7 to the fourth, minus 3, parentheses, x minus 7 squared, plus 4 times x minus 7, and then minus 5. And so again, I replaced all the x's with that form, and then shift 8 units up means I'm going to add 8 to the rest of it. Now, if you put 8 inside the bracket, then you made a big error. Because if 8 was inside the bracket, the plus 8, you would be multiplying it by 6, you would actually give you a vertical shift of 48 units instead of 8. Very common error. Alright? So there's one of those common errors that people make with the easiest transformation is the vertical shift, and they screwed up because, for whatever reason, and that vertical shift always has to go outside of everything else. It can't be multiplied by a number. And so there it is, a big function. It would be very unproductive to multiply this out. I haven't mentioned this, but when you make these transformations, I would not simplify it. All right? Because in this transformed form, if we were comparing this function to that function, we'd be able to look at this and tell what's happening by thinking in terms of transformations. And however, if this was all multiplied out, it would be a very long process to do so. You would get very large numbers, and you wouldn't be able to recognize any of those transformations either. So it would be actually very counterproductive to multiply that out. So there's kind of an exception to our simplifying things that we normally do in algebra. All right, finally, let me kind of quickly recap why we do all this. And for one thing, it's a great algebra topic. How do these transformations affect things, behavior of functions? People who use math, professionally, like engineers and scientists, it's to their advantage to be able to learn how to analyze the behavior of functions. Because if you could take a physical situation and describe it, accurately in terms of some algebra equation or function, then you may be able to use some of these techniques that we're uncovering in order to determine the behavior. Understanding the behavior of a function really leads you to understanding the problem itself and how to solve whatever it is you're looking for. So that's important. As far as math modeling, it's important. For example, these vibrations, if we modeled vibrations using a sine wave, then we need to take into account vertical stretches, which might be related to energy levels, horizontal stretches, which would be related to frequency or period, what we call it. Horizontal shifts would be called phase shifts, and actually you probably wouldn't even think about vertical shifts in that case. They wouldn't have a role. But as far as wave patterns, in order to create a function, in order to understand it, then you need to be able to apply these to fit the information to the right curves. I've done this with music, and you can take, for example, two different notes played together. If you represent them by frequencies, you can turn that into a mathematical function And by looking at the graph, you get some kind of idea of why is it you're hearing what you're hearing. And that's another big topic which I could talk about for a long time, because music and math is a great interest of mine. But anyway, that's kind of why, to give this, if you want a reason why people study transformations, beyond that it's just a great algebra topic, is because people use algebra, use function transformations in order to understand behaviors of functions, or to fit functions to certain physical situations.